Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about a new subject, digital image processing. This is going to be the very first video in this particular subject. So we're going to see the introduction about digital image processing. We're going to see the overview of the syllabus, and we're going to see why is that you have to study digital image processing, and what are the important concepts in digital image processing, what are the applications in digital image processing. So these are the topics which you're going to see in this particular video, and this is going to be just an introduction of digital image processing so that you can understand the overall syllabus of this particular subject, right? So before starting with the overview of the syllabus, we will start with introduction with digital image processing, right? From the name itself, we can understand what is digital image processing. That is processing an image, right? I can give you a very good example where you people take a picture in your mobile, right? And you will try to enhance that particular picture by using some filters, or you will enhance the brightness and all those things, right? So all these processes are called image processing, right? And technically we can say image processing on two major tasks. One is improving the pictorial information for human interpretation. Another one is processing the image so that we can transmit, or we can able to get the information from that particular image, or in order to represent an autonomous machine perspection, we can also process the image for that particular sake, right? So image processing is on two major tasks. As I said, it can be improvement of pictorial information for human interpretation, and processing an image for storage, transmission, or for any autonomous machine perspection, right? And today we are in computer vision era, right? That is an era where influenced by artificial intelligence, correct? Where we are making the system, we are making the computer to understand about the objects, right? About the process by looking at an image, right? We are just training the system to understand the object by looking at the picture. It will identify the objects, it will identify the pattern of that particular image and all those things, right? And we can say that particular technology as computer vision, right? And this computer vision is evolved from digital image processing, right? And whatever we are trying to do, the machine to recognize a particular image, to identify an object, right? To identify a scene, right? Everything comes under basics of digital image processing, right? So the computer vision is an evolution of digital image processing. And we can say digital image processing, when it comes to a computer vision, we say that it is a high level process, right? For a normal digital image processing, it can be a low level process, okay, right? So we can categorize this particular evolution from digital image processing to a computer vision into three different processes. That is low level process, mid level process, and high level process, right? And we can also see in other perspective, like processing an image can be of different levels. That is low level, mid level, and high level. Where in low level you will just give the input as an image, and output will be an image. That is, what do? You take the picture, right? You will just increase the brightness, right? You will add filters, something like that, correct? That is, you are eliminating the noise of that particular image, right? You are sharpening that image. That can be a low level process. So input will be an image and output will also be an image, right? And mid level process is nothing but input will be an image and output will be the attributes. That is the recognition what we obtain from that particular image. That is identifying the object or segmenting that particular image. That is called as attributes. It is called mid level process. And what is high level process? Understanding that particular image. That is, we are making the computer to understand that particular image, right? That is the high level process where the input will be attributes, right? And output will be understanding, right? Understanding the scene or autonomous navigation, something like that, right? So that is digital image processing, right? And being a CSE student, you should definitely learn this particular subject because you know the importance of computer vision, the influence of artificial intelligence, everything, correct? Right? And this digital image processing is a basic step for computer vision, right? And when we say about digital image processing, there are different concepts, and there is 4 important concepts you have to know about it, right? And your syllabus is completely based upon these 4 concepts. First one is image enhancement, another one is image restoration, the third one is image segmentation, another one is feature extraction, right? What is image enhancement? So when I say image enhancement, as I said the previous example itself, right? You take an image, you enhance it, right? According to the human perspective, different person will have different level of brightness, right? Different filters and all those things, right? You can see this particular picture where this particular picture is not clear. So it is enhanced in like this so that it is clearer than the previous one, right? That is called image enhancement. You know that very well, right? And what is image restoration, right? You have to be very clear with the image enhancement and image restoration. See, image enhancement, as I said, it just enhances that particular image. Similarly, image restoration also we are going to do the same thing, but here image restoration in the sense from the word restoration, you can understand you are restoring that particular image, right? Some image will be very poor, or it will be very old, right? And you will try to get the information, or you will try to enhance that particular image, or a completely blurred image is restored to a normal image. You can see this particular image, it is completely blurred, right? And you can get, you can enhance it to a bit in such a way that you can see the right hand side, right? So this is called image restoration, restoring the broken image, that is getting the uncorrected information, uncorrected versions of the image, that is called as image restoration, right? And the third part is image segmentation, right? From the name itself you can understand image segmentation is just, it will reduce the complexity of the particular image, that is we will be segmenting the image, digital image, into different subgroups, right? That is one part of image processing. Why is that we go for segmentation? We can able to analyze the image in more detailed manner. We can reduce the complexity of that particular image, and as well we can able to identify the objects clearly if you want to segment the image. That is called as image segmentation, right? And the last one is feature extraction, right? What is the feature extraction is? That is extracting the pattern of that particular image, right? You will be understanding the pattern of that particular image. With that particular pattern, you can able to reconstruct a new set, right? That is called as feature extraction. We can also say that in a different way, that is preserving the essential elements of that particular image, right? And highlighting the elements, highlighting the key elements, right? That is called as feature extraction. You know what is cloning, correct? Right? That is, you will obtain some features of the original one and you will try to reproduce a new one, correct? Similarly, you will try to observe the pattern, right? You will try to have that pattern, and with that pattern you will construct a new one, right? That is called as feature extraction, right? And my dear students, you're going to study all these basic concepts in this 5 units, right? And we will see syllabus, and before that we will see what are the applications of digital image processing, right? So as I said, it is just computer vision is just an evolution of this particular digital image processing, correct? And digital image processing right now is used in almost all the fields, right? The advancements in all the fields, we use digital image processing, right? That is image processing and restoration in medical field, remote sensing, transmission encoding, robot vision, color processing, pattern recognition, video processing, microscopic image, and right now we know about the importance of fingerprint recognition, face recognition, face detection. All these applications are only because of digital image processing, correct? And you can see a very good example of this, where you can see this part is an X-ray image which is not clear. It is enhanced so that it is clear here. Similarly, you can see this is the satellite image which is not clear, and you can see it is enhanced such a way that, and this is a medical image technique where this image is not clear and you can able to segregate objects, or you can able to diagnose clearly in this particular image. And you can see this is for weather forecast, You can see this particular image is the enhanced one, right? So almost in all fields we will use digital image processing, right? And it is a very important subject to learn in this particular second year, right? And before starting with the syllabus, I just give you right now you'll understand what is digital image processing, right? So how can we define a digital image, right? A digital image can be said as a two-dimensional image with finite set of digital values. We can call it as picture elements, pixels, all those things. Okay, but mathematically, how we can say it as a two-dimensional function. We can consider a digital image as a two-dimensional function like this. We can represent as f of x comma y, right? Here it is mentioned as two-dimensional image. I would say this as a two-dimensional function mathematically, where x and y are space coordinates. X and y are space coordinates, and f, the amplitude of f speaks about the intensity of that particular image, right? The intensity, the grayscale of that particular image, right? So how can we say this as a digital image when f, x and y, when all these components are finite, right? When all these components are finite and discrete, we can say this as a digital image, right? We can say it as a digital image, and whatever processing which is done on that particular image, that is called as digital image processing, correct? Right? And this is a simple diagram where you will get the digital image output, where you know that you will use a digital camera, correct? But technically speaking, you need a scene which we need to convert an image. You need an image system, and you need a light source, that is illumination, to take a picture, right? And the final output you will get a digital image here, correct? Now you understand what is a definition of a digital image, right? And these are the other important definitions where you have to understand the difference between image processing and pattern recognition, right? So image processing, as I said, enhancing an image, correct? Like basically that is manipulating the basic characteristics of the image, such as color, brightness, contrast, edges, all those things, correct? What is pattern recognition? Pattern recognition is how you classify that particular image, what you identify from that particular image. That is called as pattern recognition. You can see here classification, listening, identification, symbolic description of features or aspects of an image. What you study from that image, that is called as pattern recognition. You have to know the basic differences, right? All these are important definitions in digital image processing, right? And we'll see the overview of the syllabus. As I said, we're going to study only about those basic concepts in digital image processing, right? And even though I said that four different processing, that is image enhancement, image restoration, image segmentation, and pattern recognition, all those are different process involved, okay? But in that single process, if you take image enhancement, you have a lot of techniques involved to enhance the image. Similarly, for image segmentation, you have a lot of techniques involved to segment that particular image, correct? That is what you're going to study. And unit 1, it's all about fundamentals of digital image processing, right? Where you will study about what is the important elements of digital image processing. You will study about different steps in digital image processing. What is the difference between image and pixel? All those things you'll study in unit 1, the fundamentals of digital image processing. And unit 2, you'll study about image enhancement, where you'll study about different enhancement technique like smoothing, right? And what is histogram processing? What is about sharpening an image? What are the techniques involved? All those things you study in unit 2, right? And unit 3 is about image restoration, where you study about techniques involved in restoring an image. I said what is restoring an image, right? In that case, you study about different filters. What is the importance of filters in image processing? What is adaptive filters? What is band reject filters, band pass filters? All those things you study in image restoration technique, right? And the fourth important technique is image segmentation, right? And there is a fourth unit where you will study about different techniques involved in segmenting an image. As I said, segmenting is nothing but subgroups of the image, right? So that you can reduce the complexity of that particular image. You will study about the intensity features, right? And what are the techniques involved? What are the fundamental image compression models, right? All these things you study in concepts of image segmentation, right? And the last unit is very important unit where you can with this particular pattern, a lot of application has been evolved. That is fingerprint recognition, face detection, all those advanced techniques like neural networks, CNN, ANN, everything evolved with this particular feature extraction technique, right? So in this unit, you'll study about feature extraction techniques, right? You'll analyze an image, you'll extract the information, right? And you'll also study about ANN, RCNN, and all those things. How you will detect an object in that particular image, everything will be studied in this particular unit, right? So it is a very interesting subject where everything is conceptual. If you understand the concept clearly, you can write it by your own, okay? And in this particular video, the description I have given to download this particular book. This is the prescribed author book, right? You can download this particular book and you can study the units in this particular book, right? So today what we have seen is we have seen the introduction about digital image processing. I have just given the introduction about digital image processing. What are the application involved? What are the important techniques involved, right? And overview of syllabus, right? Thank you, students.
Thank you, students. Thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும்னு நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.